Hello, everyone. Good day. So I'm here to walk you through an end-to-end project in SQL, HR analytics. Okay, you might be wondering why I'm laughing because I've been frustrated. I've been trying to connect my SQL database to Power BI, and I've been doing this for over 6 hours, which and I feel so frustrated right now, but all the same, in case you're trying to do this project, end-to-end project with me, I would advise you to make sure that your database is connecting. If it's not connecting, no problem. I'm going to show you a better way to do this. You can always export the data and then load it into Power BI, right? So, yeah, so in case you're experiencing that with me, just skip that frustration and let's go right. Okay, so this is the project workflow, what we'll be doing. We're going to be given an introduction, which is the funny introduction I've just given now, right? And we're going to be looking at the business aims and objectives. Also, looking at questions that have been thrown to us by the stakeholders. We're going to be creating a database, developing SQL queries, and connecting our Power BI into the database, which, well, seems to be a major problem for me now. Then also we're going to be visualizing our data and giving summary of our findings, which is the answers to this question thrown to us by our stakeholders. Okay, so business aim and objectives is simply as follows. Hilltop Group is a fast-growing business in the heart of Lagos, Nigeria, right? Basically they have a business, their headquarters is United States, and they're seeking to, expand in Nigeria. But first, they want us to develop a database for their outlets in the US. And as they are new into the industry, which means that they have just knowledge about database management, they've employed the services of Daniel Analytics due to lack of skilled personnel in their company. They want Daniel Analytics to build a database, analyze and communicate insights through visual storytelling. And these are some of the questions we want us to answer. I'm just going to touch 3. The questions are available in the GitHub. So you can always go there and access the questions. Maybe take your time and just read the questions in the GitHub. So the first question is, what is the gender breakdown of employees in the company? What is the race, ethnicity breakdown of employees in the company? And also, what is the age distribution of employees in the company? So everything you need to know about this project is in the video description. Where to download the data set. The README file, you just have to click on my GitHub repository, which my GitHub link, I'm going to be dropping in the description. And this is another part of the question that we're going to be looking at just to save time and help you guys here and to keep you guys in the boring video. I want you guys to just read this through. Okay, so the next thing we are going to be doing now is creating our database. I'm going to be going straight to my SQL, using my SQL for this project. Going straight to my SQL, and I'm going to be creating the database for Hilltop Group. Awesome. So these are like all the databases I have so far. I'm going to be just creating a simple database. This should be 8 database, and the name of this database is going to be Hilltop Group. Awesome. So I'm just going to run this, and I'll wait. Awesome. So it's done. Refresh this, and I have Hilltop Group, okay, as our database. Okay, so how do we import our data set, right? We need to import our data set. We don't want to start creating tables because this is already made available for us by So what we just have to do is we have to import the data set, right? We have to import the set. This data set, the link to download this data set is available in 2 places. One, I'm going to be sharing the Google Sheets link, on the video in the video description, and also the dataset is available for download in my GitHub repository. So I will just share my entire screen. There you go. Awesome. So I'm going to right click on tables, and I'll just click on table data import wizard. So I'll click on browse, and this should take me to where my data. Go to downloads. I have this here. And resources, right? I'll click on open. Then I'll just click on next. So I want this to create a new table on Hilltop group. Okay. Then drop table if exists. Then click on next. Awesome. So now we have a preview of the entire data. So this is what we have. Preview of the entire data set. Okay, so this data is ranging from 2000 to 2022, something like that. Yeah, then we have all these stuffs. Okay, I'm going to have to do some changes. So erase this should text. Then the birth date should be hey, I will just make. I'm going to leave everything the way they are. Okay, just to be sure. Then the data is in UTF-8, the way it should be. Then so I have everything set. I'll just click on next. Just to be sure I have everything. Now we're here, so I'm going to just click on next. And it's going to take some time. So while this is loading, I'm going to walk you through the entire data set. Okay? So this is our data set, and well, this is ID, the first name of the employee, the last name of the employee. We have the birth date. So we might have to do some cleaning on this with SQL because it's not really probably in the same format. We have 11-02-17, we have 3/17/1994. So we have to clean this with SQL. Then we have the race, department, job title, and hire date. So hire date and birth date have to be cleaned in formats. Put them in the right format with SQL. Then the term date, which is termination date of the employee. Anyone that's blank, which means they're still working with the company. And most likely we are not going to be using we're not going to be using the time, so we'll have to clean this column. Then I think every other thing is okay. So when we take this data set to SQL, we have to do some cleaning. And the queries I'll be using for the cleaning are going to be available to you guys in my GitHub. You just have to look at the queries and do them as you want to, or wherever it is. Okay, so let's head back to SQL to see if our table is successful. Okay. If this is still loading, we'll just have to wait. Okay, so I'm going to go back to the data sets. So this particular data set, we're going to be doing cleaning for every single thing here for the birth date. We want to put it in the right format so that I will be doing this with SQL, showing you how to do this in the right format so that we are not going to have issues when running or doing our visualization. Awesome. So now we can see that our data is finished importing. We can just click on next. And click on next. And we can say finish. So when we click on finish, this takes us to MySQL Workbench. Awesome. So now we have our entire data ready. I'll just go to database. I'm just trying to make this. So I can see, so I want to view all the data we have in MySQL Workbench. But before I do that, I'm going to tell SQL that I want to use the Hilltop group. The Hilltop group database. So I'll just say use Hilltop group and run that query. So SQL. Oh, okay. Oh, okay. I have the wrong name for the database. So I'll just run this again. So now SQL recognizes that I'm using the Hilltop group. Okay, now that sounds fair. Okay, so now the next thing we're going to be doing is that we're going to be developing our SQL queries. We're going to be cleaning our data, right, with the use of SQL, which means those data, the date column, we have to clean them. The higher date, the termination dates, every one of them has to be cleaned. Okay, so I'm going to be doing this, but I might not be explaining everything in the video. But not to worry, I'm going to drop a comment under each code to tell you what I was doing after each code. So you're going to have to actually be guided, maybe not by me, but I'm going to write the SQL queries. But at the same time, I will drop a comment describing the code or the query that I was writing in my SQL work. Okay, so the first thing I will be doing is awesome. The first thing I will be doing is I have to select all the data, select all from Hilltop group. Okay, so I'm sure you guys understand this particular query. Select all from Hilltop group. Okay. Select all. Okay, what's the name of this query? Okay. Now I'm really confused. I don't really know the name of this. So, I can't actually remember the name of my table. This is funny. Okay. First to show. I need to. Okay. So going to. I'm just going to alter this table. Which means I want to change the name. The name is not really. I'm going to put underscore. I'm going to change the name to HR. Okay, then I'll apply. Right. So I'm going to come back to this and just write HR here, just to be on the safe side. I wasn't sure of the name. Select all from HR. So now I can see all the information here also. I can see all the information here, and it's now beginning to make sense. So which we can see the ID, we can see that the ID name is kind of having issues, but we're going to fix that. Then we have the first name, last name, birth date, and so on. So the first thing we have to do here is we have to alter the ID column. Okay? We have to alter it. That means we have to actually change it. The name is not really good. So I'm just going to. So what I'm going to do is I'm going to say alter table. Okay, then this should be changed column. I'm going to copy name. I'll paste it here just to be sure I have the right name. Then I want to change it to employee underscore ID. Then I want the variable type to be varchar. Has like maybe 10 characters there, but I'll just put 20 just to be sure. Then I will say this is null. My semicolon, and I'll run this. Awesome. So just to be sure if that actually works, I'm going to say select all from HR. Okay. Select all from HR. So I have this employee ID. I've actually claimed that particular column name. Select all from HR. So that's how we are going to view everything we have. Okay, so the next thing I want to do is I want to now look at the data types of our table HR. So I will have to describe HR, which means I want to see the data types. I have to run this. Now I can see employee ID varchar in its right data type. Then I want to change the birth dates, the hire dates, and term dates. Okay, I want to change the data types. So what I'm going to do is I am going to write a query that selects select birth dates from HR. So I want to see the birth dates from HR and see how the format is. So these are the formats we have, which means we have to change this in its right format. Some of them are actually, all of them are in the text form, and some of them are not properly arranged. Some of them have the dates, the months in front. Some of them have the months in the middle. So we want to change that. We want to show that we have the right data type. Okay, so what we are going to do is we are going to run a particular query. Okay, what we have to tell SQL is okay, so what I'm going to do is I'm going to set I'm going to actually try to save what I've done so far. So I'm going to run this. Okay, then I'm going to run this also. So what I want to do now is I want to update. I want to actually clean this particular column, okay? And to do this, we're going to use a case if function. Telling, okay, I don't want to explain this. I'm just going to run my code. Okay, so this will be update HR. Never worry, I'm going to have a comment that actually explains this code. Set birth date equal to case. right? Okay, I'm just going to copy the entire code. I'm just going to, this is just a waste of time. So what I'm going to do is I'm going to copy I already have it written down, done this project before. Then I'll copy the entire code and I'm going to run this. Okay. I'm going to run this. Awesome. So I'm going to select all from the HR table and see the changes I have made. Okay, so if we go to birth dates, we can see that everything is now properly arranged. We have the birth dates, everything in check. Okay, this is not probably making sense, but well, let's focus on the changes we've done. I don't want to overthink this. So we have birth dates looking all good. Perfect now, right? We've done cleaning, everything is in check. Okay, so for the explanation of this code, I will just copy this here. Okay. So you can always refer to this to the SQL text file. Okay, always refer to the SQL text file. This explains the code. Awesome. So we have the explanation for this code, for this particular query. Then this is the explanation. So this is how I'm going to give you the explanations for all my queries, right? All my queries. So I don't have to spend time explaining it in person. But however, how I'm going to explain it in person is still the same way I decided to write it. So all the same. So the next thing I want to do is I'm going to alter the table, right? Change the data type to date. Let's run this and to be sure if this is good enough. Still, the query is still running. All good. So I'm going to run this. Awesome. So I have everything done for the birth date. I'm going to do the same thing again for the higher date. Right? I'm going to do the same thing for higher dates. And when I'm done with that, I'm also going to want to alter the table. Okay, so this query follows the same explanation as that of the birth dates query. So just the same thing. I'm going to run this. Then after that, I'm going to run this too. So I'm just doing the same thing I did in the birth date column. Then I'm just going to copy this and bring this down so I can always refer to it. Easy to refer to it. Then I'm going to run this. So for the higher dates, we have this. Awesome. The higher date is set, perfectly cleaned. Then the next thing we want to do the same thing for termination dates. Okay. We want to do the same thing for termination dates. The same cleaning, right? The same cleaning. Then going to run this. So I think the explanation for this was just slightly different. So I'm going to put here and what's the explanation? So still the same thing. All I'm just doing here is I'm trying to make sure that the date column are very are easy to understand because we're going to be taking this data to Power BI. So we want the date column to be easy to understand. We don't want it to be messed up where we have to start doing cleaning again with Power BI. I mean, that's going to be like a long work. And imagine if you're not the person, actually cleaning this data. Imagine if you're not the one doing the visualization in Power BI. That's going to be like a lot of work for whoever it is that has been tasked with the job of doing the visualization. But when the person sees that, oh, this guy has actually done this cleaning for me, I mean, they'll be grateful, right? It might actually take you out for lunch. For you. So the next thing I want to do now is do the same alter table, right? And just one. Then I'm going to run this. Okay, I'm going to run. Then I'm going to select all each child to actually see if this will work. Then I'll just run to term date. Awesome. So anybody that is not yet terminated, I think this is an error. So anybody that has this particular date format in their termination date, which means they're still in the organization, so we would want to actually deal with that. Then the next thing we want to do is we want to add age column because we want to be able to calculate the age, and we're going to group these guys into age groups. We have to group them into age groups. We can use Power BI to do that. So I'm going to add a new column called age, and the age I want the data type to be in integer format. So I'm now going to tell SQL that I want you to subtract their birth date from the current date. So current date is today's date. Subtract their birth year or their birth date from the current date, and that will now be their age. So I'm going to run this query. SQL should do that successfully. So I'm going to select all from child. Then I'll go to the age. So we can see, okay, this is minus 42. This is funny. So we can see 31 years, 38 years, 33, 40, and so on and so forth. Okay, so that is done. We've added a new column called age. So what I'm just doing here is data cleaning. We could actually do this in Power BI. Yep, we can do this in Power BI, but it's sweeter working with SQL when you can also just do your visualization in Power BI. So the next thing I want to see is I want to look at the maximum age and the minimum age in our data. Okay, just want to be sure that that is put in place. Okay, I don't think I have my description. Yeah, so I'm just going to write this SQL query as a new column called age. Okay, then here we are just trying to this whole subtract. Okay, so this code subtracts the current date from, okay, subtracts the birth date from the current date, which is today, right? Current date is today. So, hey, current date, which is today. So, I'm going to run this. Awesome. So we're looking at the youngest age is minus, which is pretty wrong. I don't know why we are having this issue here. Where was that mistake? Birth dates. I'll just leave it on there. All I can do, I think I'm going to use Power BI to actually delete these records, these particular records, so we don't have errors in our data. Okay, so the next thing I want to do is I want to tell Power BI, okay, I want to tell SQL, sorry. So I want to see the number of people in our data where their age is less than 18. Okay. So 967 employees have their ages less than 18. Then what I also want to do is I want to count the number of people that have their termination dates greater than the current date, which means how many people have been terminated so far. Because if it's not greater than the current date, 00000 cannot be, I mean, it's not greater than today's date, right? So the people where their termination date is greater than the current date is going to give us the amount of numbers. So we have 1,585 people have been terminated, right? Okay. So the SQL code, okay, this SQL code is actually counting all rows in the HR table where the termination date column is greater than the current date as determined by the current date function, okay? So the where clause is used to filter the rows based on the condition that the term date column is greater than the current date. So the count function is then used to count the number of rows that meet this condition. Then the asterisk symbol, so I'm giving a very basic explanation. The asterisk symbol is used as an argument to count to the count function to indicate that all rows should be counted. That means the rows that meet the condition. So in summary, this code is selecting the count of all rows in the HR table where the term date is in the future, okay, meaning that the employee has not yet been terminated, right? So if their term date is in the future, it means that the employee is not yet terminated. So I'm going to drop, okay. So what I then want to do is I want to count the number of people. I'm just going to run this code. I'm going to explain this code. So we have 18,285 people, right? So this, okay. So we are the term date column. Sorry, I have to share my screen again. So where the term date column is equal to 00000. The where clause is then used to filter the rows based on the condition that the term date column is equal to 00000, right? We have some termination date column where the value is 000. So the count function is used to count the number of rows that meets this condition. That is a where clause condition. Okay. Then the asterisk symbol is used as an argument to the count function to indicate that all rows that meet that condition should be counted. In summary, this code is selecting the count of all rows in the HR table where the termination date is equal to all zeros, which may indicate that the employee has not yet been terminated or that the termination date is unknown. Okay, so the number of employees that have not been terminated here is over 18,000 employees. Okay, so I then want to see the locations we have in our from. So we have headquarters, we have people that are in headquarters, we have people working remote. Okay, we have people in the headquarters, we have people working remote, and so on and so on. So I'm going to be dropping the description of this SQL query into this file. So if you have this file, you're just going to see the description where I made explanations for this particular SQL queries, so you won't be left confused along the way. Okay, so the next thing we want to do now is we've done our cleaning, because I'm going to, all we just did here is exploration, but we've done the basic cleaning, which is cleaning the birth dates, cleaning the hire dates, and also cleaning termination dates. Okay, so we are going to go to SQL, and we're going to go to Power BI, connect this data set to Power BI, and make our visualizations. Okay, so if you're able to connect your data set to Power BI, awesome. But if you're not able to connect your data set to Power BI, you can export this particular data set by clicking on export, this export symbol here. Then you can actually do that in export it using in a CSV file format. Then just click on save. Type in the name you want, click on save, and that should do. Okay, so the next thing we are going to be looking at here is where we have to connect our database to Power BI. So if you're able to do this successfully, kudos to you. I don't know, I tried mine for close to 6 hours, couldn't work for me, and which was actually disheartening because I wasn't able to eat food. So it was really, really painful. If you're able to do this, wonderful. But if you're not able to do this, please export your data set to a CSV file, then load it in Power BI. So, wonderful. The next thing we want to do now is connecting Power BI to the database. You can do it by connecting to your local host server, or you can download the data set, load it in Power BI as text CSV file. Awesome. So now we want to connect our data to Power BI, right? But before we do this, we have to answer those questions that were given to us by the stakeholders. Once we're answering these questions, all we just have to do is run these queries, get the outputs, save them in a CSV file, then take them to Power BI to make our dashboard. So we don't really have to, we don't have to start exporting the entire data set into Power BI. We can just answer the questions here in SQL, so it's easy for us to make our visualizations using Power BI. Okay, so I'm going to open, I already opened a new query file, right? So I will just click on this. This will be where I'm going to be answering my questions. I'll just make this a comment. So this will be question 1. So we already know what the question 1 is right from the slides. So you can have access to the questions in my GitHub repo. Easy for you to run. Or you can, I'm going to be making the slides available, right? So you can have access to the slides view only. So the first question is, what is the gender breakdown of the employees of the company? So I will just make this question. Okay, so what I'm going to copy the questions and paste them here. So what is the gender breakdown of the employees of the company? Right, so for us to get this will be select gender, because we have a column called gender. Then also count, let's say count all as count. Then this will be from our table, which is HR, where age is greater than or equal to 18. Okay, so we are running this for ages that are greater than or equal to 18 because remember we had some errors where we had people's ages that minus 46 is not right. So we definitely have to discard those because they contribute to less than 10%. Those are outliers. So they contribute to less than the entire data. So we can discard them. Okay. Then we want to group by gender. Okay. So this will be then I'm going to put my semicolon and run this. So this should give me awesome. So now we can see the male count is 10,794. Female is 9,876. Then non-conforming. Non-conforming is 577. Non-conforming could be those that did not specify, or maybe we don't know. I don't want to say people that are transgender or something, right? We don't want to say that. We don't want to assume. So we have male, female, non-conforming, could be anything. So all I just have to do is export this and put this as gender question1. Easy for me. So it will be easy for me to actually export this file and locate this file in PowerBI, right? So I'll just save this. Then we have our next question that was asked by the stakeholders is, what is the race ethnicity breakdown in the company, right? So just similar to the gender, we are going to also run this. I will just copy this because we'll be running this almost the same query, but changing. So we're going to do race. Then from HR, where age, so we want to group by race, right? Then we want to order by count, which is this count. We want to order it by this count. Then we want the order by to be in descending order. So what we're just telling SQL here is select the race column, count it, right? Count everything we have, everyone we have in the data set. Count, select the race column from the HR table where the age is where the age of the employee is more than 18. Group it by race so we can get the total by the race. Then order it by the count. So in descending order, starting from the highest, right? So we want the count of this stuff to be from the highest. So we start from the highest, then to the second highest, down to the lowest. That's why it's in descending order. So I'm going to run this. And also, we have this as our output, right? So all we just have to do is export this also and say, we want to store it as race question2. Easy for us to locate, right? Then we have our next question, which is, what is the age distribution of employees in the company? What is the age distribution of employees in the company? So this is going to be select. So I want this to be mean age. That's the minimum age as youngest. Then the next one we're going to have is max age. Okay, mean age. So what I'm going to do, I think I'm going to, before I run this, I'm going to have to run a particular query that deletes every single age that is less than 18 from our data set, right? So I think that's what I'm going to do. So I don't, because if I should run this, I'm going to have max age as, let's see, oldest, okay, from HR. I want to show you the error I'll be getting. Here, age. Okay, I don't think I'll have to do that. Let me make age greater than or equal to 8. So let me see if my output will give me what I'm looking for. Awesome. Okay. So because if I don't run this, so I'm going to just put, if I don't put where it's greater than this, so I'm going to be having minus, yeah, this is what I was avoiding, right? Minus 46. But what I just did now made that easy for me. So because of the where clause, I've been able to discard the ages that are negative, because we have negative ages. I really don't want that error in my data set. I don't want it to affect my outputs. That's one thing we have to be sure of. I could easily delete the rows where the age is less than 18, right? I could easily delete the rows where the age is less than 18, but using the where clause here makes it easy for me to actually walk through that. That is what I'm looking for. Yeah, so this is the age distribution, right? So I'm going to save this as question 3, age question 3. So it will be easy for me to walk through. Okay, so now we move on to the next question. And the next question is simply, okay. All right, so still in that same question, we want to put our ages in groups, right? We want to make our ages, we want to group them. So age groups, we want to make age groups, make it easy for our data to be worked. We are going to say age. So let me try and, so we want to actually, what is the age distribution, right? So we've not even finished. We are not done answering the question. So the first thing we want to do is we want to find out the minimum age and the maximum age. So this is going to help us understand how we can group ages in our data set, right? So we want to find out those that are in their 20s, those that are in their, because the minimum age is 20, right? So we want to find out those that are between, that are 20 years. We want to find out those that are 30 years. We want to also find out those that are 50 years and those that are, above 40 years, right? So I'll just copy my query, run code, run this. So I'm going to run this. Awesome. So now this is what we have. Okay, so what we decided to do here is to get this output. What we wanted to do is we wanted this code to count the number of employees in each age group from our table HR, where the age is greater than or equal to 8. Right. So the age groups are determined by rounding down the age to the nearest multiple of 10. That is why we have, and that is why we have those 10 divided by 10 multiplied by 10. But we did that using the floor function, right? So the results are then grouped by the age, and results are then grouped by the age group using the group by clause. Okay, which is why we are having all this. So we wanted to, which is why those that are 32 years, 34 years, they are taken to the age group 30. Those that are 41, 42, 43, 44, they are in the age group 40. Those that are 20 and above, between 20 and 30, they are in the age group 20, while those that are 50 and above are in the age group 50, right? So we made it in the nearest multiple of 10 so that we don't have ages flying around, okay? So to do this now, we then have to, the next thing we want to do is, we want to then make our age groups much better to look at, right? We want to say, okay, let's put this in those that are between 18 and 24, 25 and 34, because remember the age group we have, the highest age group we have is the highest age we have is 57. So we want to actually take note of that. But now what we want to do is we want to make, so I'm just going to divide this by what we have. Okay. So what we want to do here is we want to put our ages in groups. So we're going to use a case function. It's a long description, but I'm going to explain this later on. So we are saying if you're between age 18 and 24, then you should fall under this age group. If you're between 25 and 34, fall under this age group. If you're between 35 and 44, this is your age group. 45 and 54, this is your age group. 55 and 64, this is your age group. Else, then that means if you are not in any of this age group, then your age group should be 65 plus, right? So if you're used to Python, you would understand the if, else, elif, and all that, right? So we want it to now end as age group, which means let the name of the column age group. Then we're also going to count the employees we have in our company and then group it by age group. Remember, very important thing, where the age is more than 18, because we are discarding those errors, those negative values in our table. Then we are also ordering it by age group, right? We are ordering the whole stuff by age group, which means it starts from the lowest to the highest, which is why it's in ascending order. If we wanted it to be in descending order, we could also order by count, right? But we want it to be orderly, starting from the lowest age group down to the highest age group. Okay, so I'm going to run this and see what we have. Awesome. So now this is what we have in our data. Okay, so this is what we have in our data set. We have those between ages 18 and 24. There are 2,650. 25 and 34, 6,077. 35 and 44, 5,9. So 45. Okay, awesome. I got lost there for a moment. So 45 and 54, they are 5,616. 55 and 64, they are just 910. That is what we have as our age group. Now we want to, so I'm going to export this. We will definitely be needing this. So I'm going to export this and name this as age 2023, still same question 3, because we are going to be making another table. Then remember, this is all still question 3. Then, so now what I want to do is these age groups, I want to find out how many, so for the people that are female, how many people that are female fall under the age group 18 to 24? How many people that are male fall under the age group 18 to 24? And how many people that are non-conforming fall under the age group 18 to 24? We're going to do all that again for the age groups in our data set. So when you're going to be looking at this SQL file, I'm going to put a description to all the queries so you will actually have an understanding of explanation of everything that is going on. Okay, so the next thing I want to do now is I already have my codes. So what I'm just telling SQL is the same thing we did as before, right? Same code. But now I'm telling SQL end as age group and gender, which means we are having 2 columns, age group, then we're having 3 columns, age group, gender, and count, right? From the HR table, where the age, very important, where the age is greater than 18, then group by age group, and gender, order by age group and gender, which means that we're going to be having for 18 to 24, we're going to be having 3 different categories: female, male, and non-conforming. Then for 25 to 34, we're going to be having 3 categories also: female, male, and non-conforming. I'm going to run this so you have an understanding. So this is what, yeah, exactly. This is what I wanted to do. So we can look at it. We're looking at age group 18 to 24 for the females, 1,205 people. Age group 18 to 24 for the males, 1,381. Age group 18 to 24 for non-conforming, 64 people. So it goes all the way down, right? All the way down till we get to the last age group, right? And also doing 3 gender grouping for the last age group. So I'm going to export this data and name it age 3. Definitely, I think this is just the one we're going to be using, because it contains everything. So I'm going to save this. So now we've done the age. What is it? We've answered that question. What is the age distribution of employees in the company? But I decided to go above and beyond to group this, put in the gender so that we can know for the females in this, how many females do we have in this age group? How many males do we have in this age group? How many non-conforming do we have? Okay, so the next thing I want to do is to answer the next question. How many employees work at headquarters versus remote locations? So we want to know the employees that are working on site and the employees that are working from home, just like me. Okay. So now what I'm just going to do is, this is going to be a simple query, right? Select location. Then we want to count all the employees we have in our data and put that as count, a new column called count. Then we want to put, we're getting this data from the HR table. Now this is very important also, where age is greater than or equal to 18. Remember, we are always putting where age is greater than or equal to 18 to avoid that error. So we want to group it by location. Okay. So this, we'll just run this. We have headquarters, those working in headquarters, yeah, 15,992. Then remote workers are 5,225. So we're going to export this. This is going to be, we're going to name this as employees versus, okay, just to make it easy to understand. Employees versus 1.2%4. Then we'll go over to our next question. This question is going to be, what is the average length of employment for employees who have been terminated? What is the average length? So we're going to actually write 2 queries for this. Okay, average length of employment. So now the first thing we want to do is we are going to find the difference between dates. We're going to find the difference between the hire date and termination date. Okay, so if then the difference there is going to now give us the average length of employees, right? So we're going to round that off and divide it by 365. I'm going to just copy the code from my query file. Awesome. So what we are doing here is okay, so what we are doing here is this code, it actually selects the average length of the employees in years for employees who have non-zero termination dates, okay, and whose termination date is on or before the current date, and whose age is greater than or equal to 18. So the date difference function, you can see there, calculates the difference between the termination date and the hire date in days. Then the average function calculates the average of these differences. All right. So the result is then rounded to the nearest whole number using the round function. In summary, this query just provides like useful information about the average length of employees for a subset of employees in HR. I hope I did not just speak lingo. Okay. So what we just did here, just as you can, what I just explained, wanted to find a difference between these two dates, what we have here, right? Then that difference we can see, we want to divide it by, we want to find the average, okay? The average of this age is then divided by 365. Okay, then we'll round it to its nearest whole number. Then this gives us, then we now want to put this in a new column called average length of employment. From the HR table, right? Where the termination date, where the term date, this, and term date is less than current age, and age is greater than 18, right? This particular where clause is very important. Where the age is greater than 18, unless you're going to be having lots of errors. So which means the termination date has to be less than or equal to the current date. Someone might have decided to resign today, and some might decide to resign today. It's possible. So we want to use these where clauses to actually filter whatever result we are going to be having. So I'm going to run this. This is what we have. So we have 7, which means the average length of employment for employees who have been terminated, 7 years, right? Very important. So the round function, because you can't have 7.4 years, definitely is going to be like 7 years or 8 years or maybe 7 years, 6 months, but we're rounding this in years. We want to get the average number of years. So I'm going to export this. I'm going to export this, and I'm going to put this as I'm going to put this as length of employment. This should be perfect. So I'll save this, then we'll move on to our next question. Our next question is, how does the gender distribution vary across departments? So we want to find out, this is going to be a simple query. We want to find out, just like in each group, we want to find out in accounting, how many male do we have? How many female do we have? How many non-conforming do we have? In auditing, in business development, in software engineering, we want to find out how the genders are distributed, right? How the gender is actually distributed. So our query is going to be simple. This will be select department, right? Then we want to also select gender because we want to know the department where they work. Then we want to know the gender, and we want to know the number of employees for each of these for the department, which is why we're using gender. Then we want to say count or as count. Then definitely we are getting our data from the HR table. Now this is a very important stuff where age greater than or equal to 18. Then group by, want to group by department. I'm already writing the code in mind, writing what I'm thinking in my head. Group by department, gender, then order by department. Okay, very important to order by department. Why we're ordering by department, you just let it be in alphabetical order, nothing more. You can choose to leave that, it just gives you everything scattered. Okay. For example, if I run this, I get an EBS, is not really ordered. So using my order by makes it order. Awesome. So now we have accounting. For accounting, we can see that. Awesome. For accounting, we can see the females are 1,462. Male is 1,640. Accounting is then non-conforming is 90. We can also see the same for auditing. Auditing has no non-conforming. Then business development has the three gender distribution in them, right? So now we are going to export this. First, we shall export it. Now we're going to export this, and we can call this gender distribution. This should be question 6. Awesome. So now we move on to the next question, which is what is the distribution of job titles across the company? Okay, this is just going to be similar to what we just did for the gender distribution. Okay, so I'm going to copy the code so I don't have to write it again. So here I'm just selecting job title. Okay, job title of the person, not department this time around. Job title. You can be in business development department and you might be a business analyst, right? So you can be in business development and you might be a graphic designer. Okay, so I want to get the job title, count the number of employees, put it in a column called count, as usual. From the HR table, where the age is greater than 18 to avoid errors, grouping it by job title and ordering it by job title. We want it in alphabetical order. We're going to run this. I have this. So we have web developer 4, web developer 3. I think these are great. Then we have VP sales, VP quality control. So we can also put just put department, right? So we want to know the department they actually belong in. So run this. So web developer is in the engineering department. This VP sales in sales department, VP quality control is in the engineering department. Now we can see the department where they belong to. Then vice president, I guess, marketing is in the marketing department, VP of training and development is in the training department. So I'm going to remove this. Run this. Then I'm going to save this particular file. So this should be job. This should be job distribution. Save it as a CSV file. Then I'm going to go over to the next question we have, which is okay, which department has highest turnover rate? So this one is a lot to handle, which is why I'm going to copy the entire code. It's a long code, copy and paste. Okay, so for this particular one, I'm going to be dropping the description here. So you guys can always come to read it, right? But which department has the highest turnover rate? I'm just going to run my code. Awesome. So now we can see that marketing has the highest turnover rate. Okay, because we're ordering it by termination rates. You can see marketing has the highest turnover rate. Then if we go all the way down, it's down to support, what has the lowest turnover rate. So I'm going to explain this code. When you get the file in my GitHub profile, you're going to get an explanation to the code, but okay. Then what is the distribution of employees across locations by states? is the next question, question 9. This is just similar to job distribution across the departments, right, or across the company. So here we are getting location states. There's a column called location states. We want to get that. Then we are counting all the employees we have in our table. Then from the HR table, where the age is greater than 18, we also want to group it by location states, then group by this count here. Okay? I mean, order by the count. We wanted to start from the highest. If we run this, now we are seeing Ohio has the highest employees, over 17,000 employees. Then the lowest is Wisconsin. Okay, so this answer. So what we just did here is we have a column called location states. We have to select it. We are looking for the states. We want to know the states and the number of employees in them. Right. All we just have to do is count the amount of information we have in our data, because employees are not actually repeated. So they are unique due to the employee ID. Then from the HR table, which is usual, then we have to do this, the where clause greater than 18, to avoid errors. Then we want to group it by location state, which means we want to get the total sum and group them by location states. Okay, so Ohio will give us the total sum of the employees there. Wisconsin will give us the total sum. Then we also want to order by count, descending order. Let it start from the highest to the lowest. So running this gives us this entire output. Okay, so I'm going to awesome. Okay. So I'm going to export this, and this will be location states, just to be on the safe. Yeah, location state distribution. I will save that. So I'm going to move over to the next question. The next question is simply, how has the company's employees count changed over time based on hire and termination date? If we're doing this in Power BI, we are going to be using the line plots over time, definitely long. So this code is pretty long. I don't want to get it confused. So I'm going to put a write-up so you can read the write-up over and over again to understand the code. But I'm going to run this particular file. Run this. Yeah. So now we can see the year 2000. We have 2020 in 20 years. So in 2000, they actually made 211 hires. And if we can see, I think it has actually increased over time, because apart from 2020, which is understandable because of the COVID-19 pandemic, their hires actually dropped from 1,038 to 967. They made 19 terminations, and yeah, so we can see the change. After hiring 967 people and terminating 19 contracts, the employees they were left with was 948. Right, percentage change is, net percentage change is 98.04. So this code, I'm going to drop a description to this code. When you get access to my GitHub profile, when you get access to this file, my GitHub profile, you're going to be seeing an explanation and everything you need to know about this code. The lengthy codes, we have explanations on them. Okay. Then okay. So we could also, or I could also write this in a different way. I think I would just have to, because I wrote these two different codes for this, two different queries for this particular stuff. I'm going to put this here. Gives me the same output, but gives me the same output. Awesome. So this is what we have here. If you check it, the same output, everything is the same, just different queries. So I'm going to be putting an explanation to these two different queries, but they are giving you the same output. So anyone you feel comfortable using, Awesome. Then for the last question, what is the tenure distribution for each department? What is the tenure distribution for each department? This will be, I'm going to copy the query and run this. So I'm going to explain this. Okay, I'm going to explain this. So, okay. So what I was actually trying to do in this code is that I'm trying to select the department and the average tenure in years, right? For employees who have non-zero termination and whose termination date is on or before current date, which is why we have less than or equal to current date, and whose age is greater than or equal to 18. So that particular function, date diff, calculates the difference between the current date and the termination date in days. Okay, and the average function calculates the average of these differences. The result is then rounded up. So I just decided to round up the result to the nearest whole number using the round. Okay, the results are grouped by the department using the group by clause, which allows you all to see the average tenure for each department separately. Okay, so I had to do it for each department separately. Then the query now, it will help provide insight into the retention rate and employee satisfaction level for each department within the company. Okay, I'm going to try and write a description for this when you have access to this file. So now we've answered all the questions, right? We have answered all the questions given to us by stakeholders. So now what we want to do is to take this particular file and make our visualizations in Power BI, right? So what we are going to do now, we're going to open Power BI, try to export this data set. Okay, I've not actually saved this. This should be tenure. I'm going to save it as tenure, right? Then, yeah. So next thing I want to do now is go to Power BI and make my visualizations. Okay. Awesome. So now we are done with answering the HR questions. Okay, so what we want to do is take this CSV file that was saved and take them to Power BI, right? We want to save the CSV files and take them to Power BI. So what I'm going to be doing, I'm going to be sharing my screen on Power BI. I have already exported my data sets, right? They are already in Power BI. Yeah. The questions we have, I think they are total of 9 questions. So I'm not sure. I guess some are left. I haven't brought in all my data sets. So we have 4, 5, 6, 7, 9. Okay, so I'm going to be doing visualizations for these 9 data sets. And so the first question is, what is the gender breakdown of the employees at the company? Definitely, gender breakdown, I guess I would just use a donut chart. I'll just use a donut chart and drag this here. So, this should be, okay, gender breakdown. I think this should be question 1. Then I want to put in the legend should be gender. Then I want the count to be values. The count should be in the value. Power BI always makes recording videos always makes Power BI really slow. So, I'm going to try this again. Awesome. Now, here I have my gender breakdown. Looking, I'll just try and enlarge this to get a better. So here we have 11,000 people are in the male category, 10,000 people are female category, and 1,000 people are in the non-conforming. So you can see the percentage contribution, the percentage contribution they make. Then we can go ahead to you can edit your colors and every other thing you want to do. I'm not going to do that. That's going to really take time. I'm sure you guys should know how to make dashboard designs and all. However, the next thing we want to do is to click on the next question. What is the race ethnicity breakdown of employees in the company? That should be essential. Then I will just bring in another pie chart. So I'm going to check the columns we have here. We have race. Race should be in legend. Okay. I wouldn't want to use a pie chart because we have so many categories there. So I'm going to take out pie chart and I'm going to use stacked column chart. Okay, so this should be better. So my x-axis is going to be the race, which is the categorical variable. Okay, then I'm going to take this. Then the count should be in the y-axis. Awesome. So this should give me what I'm looking for. Yeah, so now we can see white are actually the highest race in the company. We can see them at a total of 6,057 are whites in the company. Then Hawaii actually have the lowest, followed by the American Indians. Hawaii is like 1,076. American Indian is 1,273. Then awesome. So the next question we want to tackle is what is the age distribution of employees in the company? Remember when we did the age groups and all? This is where we are going to be handling that. Okay, what is the age distribution? So we can see the data sets here for this. Age group, count, and gender. Right, so here we are going to be using clustered column charts. Because we have two categorical variables. So we want to represent both of them. Yeah, so the age group is going to take the x-axis. Then the gender is also going to take another x-axis. Then we have our count in the y-axis. Let's see. Okay, I don't think it's going to. I'm going to take out the gender. We're looking at age group, just age group. Okay. So for the age group, we can see we have. I'm thinking of doing this in ascending order. And go to more options and sort axis age group. Also, let me see if this arranges itself. So I want it to be in ascending order. Okay. So 18 to 24 should come first because I'm sorting it in ascending order for age groups only, not by the count. Okay. Then I can bring in the gender in the x-axis. So here we're going to be having, for 18 to 24, we can see the gender distribution. For 25 to 34, we can see the gender distribution. For 35 to 44, we can see the gender distribution down to 55 to 64. Awesome. So for 55 to 54, we have 441 people are males, while 440 people. Okay. Then the next thing we want to look at is how many employees at work at how many employees work at headquarters versus remote location. Okay, so here we have I think we save that as employee versus. How many employees at work work at the headquarters, which means they work on site or they work remote. So here we can use pie chart to do that. Just reduce this, maybe not complete everything. So location will be legend. Then we can have our count as values. So this should make it easy for us. Awesome. So now we can see the distribution. That means more people actually work in the headquarters and lesser people work remotely. Okay. Then I'm going to have to reduce this one. And I'm going to have to also reduce this one. Okay. So I'm just trying to make room for other visuals. And so this should be. Don't mind the way I'm arranging my visuals. I'm just trying to make room for a lot of other visuals. Have this one should stay somewhere. Awesome. So I'm going to reduce this. Awesome. So I can choose to reduce this. I will still have space. Good. So the next thing we want to do is we want to answer the next question. What is the average length of employment for employees who have been terminated? For this one, we can just use trying to see. Awesome. Average here we can use a card, since this just gives us like a figure. Somewhat of the average length of employment. So this we can just represent this in a card. Doesn't have to be any visual. We can put this here. So this should show us 7. So I'm just I'm doing this as quickly as I can, but when you're going to have this stuff in your when you're going to access this in my GitHub page, you're going to be seeing properly designed dashboard. Going to be seeing the properly designed dashboard. Then the next question I'm going to be looking at: how does the gender distribution vary across departments and IT? So we're looking at gender distribution. And I'm going to be using something similar to this, cluster column chart. And so we can say, let's see, department. We can use the count as the y-axis, obviously. And the department is going to be in the x-axis, and we're going to have gender distribution, and also x-axis. So for engineering, we're going to be seeing we're going to be seeing, for accounting, we're going to be seeing the amount of females we have there, the amount of males we have there, and So I think I will just use a vertical chart so it can be as long as possible. This is perfect. Okay. Awesome. How's this? I think the vertical chart will actually do just. I'm going to leave this with the horizontal chart. I think that actually makes better sense. Yeah. So the next question we're going to look at is what is the distribution of job titles across companies? So I'm just going to pick one more visual, right? So this is definitely how we are going to be making our visuals in Power BI. I'm going to just pick one more visuals and I'm going to end it at that. So these visuals are going to. Okay, now that we've made our visualizations on Power BI, you can get more visuals from my GitHub record, right? I was not able to do most of the visuals on this recording because it's going to take a lot of time, and recording the video I'm using Power BI desktop makes the application on my machine. So, from our data and our visuals, we can actually say that some of the findings some of the things we're able to find out from our data set is that in Hilltop Group, there are more employees, but there are more male employees than female employees, okay, which we can see from our SQL query, also from our visualization. Okay. Also, we can also find out that the white race is the most dominant, while Native Hawaiian and American Indian are least dominant, okay, which means there are more white people working in Hilltop Group than there are any other race. And the youngest employee is 20 years old, while the oldest employee is 7 years old. And also, we created 5 age groups ranging from 18 to 24 down to 55 to 64. Okay, and a large number of employees were between 25 and 24, and 25 and 34 age group, followed by 35 to 44. While the smallest number of people working in the company were in the age group 55 to 64. Also, a large number of employees work at the headquarters. A large number of employees work at the headquarters compared to those working remotely, which we're able to see in our visuals. Right. Also, a large number of employees come from the state of Ohio, while the average tenure for each department is about 8 years, with legal and auditing having the highest and services having the highest, while services, sales, and marketing are down with the lowest average tenure. So there are more summaries for this HR analysis that we just performed. You can find that out my GitHub repo. I'm going to be giving a very clear view of both the questions, the queries, the visual representations, and step-by-step process you can follow to actually complete this project. However, if you like the entire process of this project, please hit the follow button, hit like, and also any questions that you will be looking to ask concerning this project. And if you want me to do more projects on SQL, Power BI, please comment so that we can know what's your preference. However, in the meantime, practice, 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 and I will see you guys in the next one.